This tutorial is designed to help you understand how to do calculations in spreadsheets, specifically Microsoft Excel. Spreadsheets are designed to perform calculations, especially repetitive calculations, on large data sets, and can do this much more efficiently than anybody with a calculator. The most commonly encountered spreadsheet is Microsoft Excel, although there are other versions. And in fact, Google Docs has an equivalent, more or less equivalent of Microsoft Excel. The formulas that we're going to discuss here today are more or less universal, but specifically are designed to work with Microsoft Excel. Spreadsheets come preloaded with most commonly used math formulations. Laboratory experiments make extensive use of spreadsheets like Excel for calculations on these data sets. In Chemistry 324, which is instrumental analysis, we find that the majority of our students have little experience with Excel and therefore hesitate to use it. One of the gifts of the course is that students are forced to become comfortable, or at least more comfortable, with Excel. This tutorial specifically is designed to talk about calculations. Well, first of all, let's talk about data entry in Microsoft Excel. The first thing you need to understand is there is a 7% error rate in manual transcription of data. Decimal places move, numbers are dropped or transposed. It's important to always check your data for errors after you've entered it. Many pieces of laboratory equipment will automatically produce a numeric file that can be imported directly into a spreadsheet, which eliminates these errors. There's a very common formatting error that I'd like to call your attention to, which involves improperly defining an input as text rather than numeric. If Excel interprets something that you've put into a spreadsheet as numeric, it will justify it in the cell, as we see in column 1 for the spreadsheet shell shown below. If it interprets the cell contents as text, it left justifies it, and you cannot conduct any math operations on a cell with text in it. So if we take a look at column 2, Excel is interpreting that as text, that you're just typing something in that cell, and is unable to perform math operations. A common error for students is to add units in a cell where they have numeric values. As soon as you put an alpha character in that cell, Excel automatically assumes it's text and will not do any calculations. We should similarly note that Excel's version of scientific notation involves E for exponent. So if the number we're looking at is 1.02 times 10 to the minus third, the way that that's input into Excel is 1.02 E minus 3. The typical inputs that people have for exponential notation, scientific notation, in calculators will not work in Excel. Excel will accept either a capital E or a lowercase e for exponential. It is important to keep track of the units for your data as you're going through calculations, but that needs to be done externally in algebra. Microsoft Excel only understands how to do calculations. It does not understand algebra, and you need to keep your algebra information someplace else, like a laboratory notebook. When we're using formulas in Excel, there's a format that some students use that is actually a misuse of Excel, and I'd like to describe that as we go through these calculations. Okay, so we always start a calculation in Microsoft in a cell in Microsoft Excel with an equal sign. Without the equal sign, Excel just assumes that you're typing text. The formulas after the equal sign can be used in two ways. If you need to do a single calculation, it can be easily accomplished by typing in equals the formula for whatever you would like to calculate, and the individual numbers separated by commas. So the calculation for averaging three numbers that look like this would be equals average, open parentheses, the first data point, comma, the second data point, comma, the third data point. You can also easily calculate things like standard deviation for the same set of numbers. My advice is to never do an Excel calculation this way. It is nearly impossible to catch a typo when you use calculations in Excel this way, and everyone makes typos. But Excel can be used as more than a calculator. And by using it, the special functions in Excel, you can avoid a lot of those typo mistakes. So to perform a math operation, we should be putting all of our data for that math operation in specific cells as raw data. Now, when we want to do a calculation like averaging, we will go equals average, open parentheses. And rather than typing in numbers, we will point at the individual cells that contain the data that we're interested in performing the calculation on. All right, so in this case, average equals the numbers found in cells A3 through A12. We can often use our mouse to highlight cells A3 through A12, making it relatively easy to type in the formulas. If we have information in multiple locations, we can separate those locations with commas uh, and then highlighting the second location. So equals average of all the numbers in cells A3 through A12 and cells B7 through H7 and Z23 through Z37. Now, the reason that it is advantageous to use this method of calculations is if you change the number in any of the data cells, the calculation automatically updates based on the new information in those cells. So if I do an average calculation and then go back and look at my raw data in those cells, and I realize that I've typed in something wrong, as soon as I correct that mistake, that correction automatically propagates into the equation that I'm using. You can also create your own calculations, such as equals the value in cell A3 divided by the value in cell B3, and the result of that calculation times 100. It's important to understand order of operations, though. That's going to take the result of A3 divided by B3 and then multiply by 100. On the other hand, if I actually wanted to take the value in A3 and divide it by the value in B3 times 100, in both in the denominator, I would have to write it like this. When we don't use the parentheses, it defaults to taking the value in cell A3, dividing it by this value in B3, and then multiplying it by 100. It's important to understand how to use those parentheses in orders of operation. In checking for spreadsheet calculations errors, you should always look for these order of operation errors, which are cured by using simple parentheses. There's a classic curse of computers. It never does what I want it to. It only does what I tell it to. We need to be educated in how to speak to Microsoft Excel using things like order of operation. The other great thing about doing things in individual cells is it allows us to copy formulas. So spreadsheets can also help us conduct repetitive calculations on large data sets. So for instance, if I have a data value in cell A1, and I would like to take the base 10 log of that, I can simply in cell B1 type in equals log of the value in A1. The formula above conducts the following operation. Take the base 10 log of the cell immediately to the left of the formula cell. This allows us to copy and paste the formula in other cells and repeat the operation. Excuse me. So I can write the formula once in cell B1 and then copy and paste that formula in cells going down the spreadsheet. Because what that formula says is take the base 10 log of the value in the cell immediately to the left of the one where I've written my formula. We should also then talk about the best way to do algebra in Excel, understanding that Microsoft Excel doesn't know anything about algebra. All it knows how to do is to calculate things. It's up to you to do the algebra and set that up properly before you ever open a spreadsheet. So let's take a look at a problem that will have some complicated algebra along with it. The problem says that dust falls in Chicago at the rate of 65 milligrams per meter squared per day. Major metallic elements in the dust include aluminum, magnesium, copper, zinc, manganese, and lead. Lead, of course, is a neurotoxin, and exposure to lead, especially among young children, can have can create lifelong learning disabilities. Lead accumulates at the rate of 0.030 milligrams per square meter per day. And the question we're being asked is how many metric tons, where 1 metric ton equals 1,000 kilograms, of lead fall on the total area of the city of Chicago, which is 535 square kilometers over the space of 10 years. Well, I'm not going to walk through how to set up the algebra on this problem. That's a different issue. But when we set up the algebra, we end up with an equation that looks like this. We set it up very carefully, making sure that we keep track of units. At the end of the problem, the only units left on the left-hand side of the equation are metric tons. That's what we wanted for units for our final answer. Once we have the algebra set up, now's the time to open Microsoft Excel and use it to do a calculation. Well, we are going to go ahead and use the philosophy previously described. Uh, I am going to take my data and put each data point in individual cells where I can see it and make sure that I haven't made any typos. I'm going to leave out the ones because I'm lazy. And I'm going to arrange the cells so that everything in the numerator is in one row and everything in the denominator is immediately in the row below it. And then finally, when I'm ready to do the calculation, I'm going to type in an equal sign. And then I will either type in or more likely point with my mouse to the individual cells. And what this formula says is take the value in cell A1, multiply it by B1, multiply it by C1, D1, E1, F1, and then divide that result by, and now we need to open parentheses because of order of operations, the values in cell A2 times B2 times C2, close parentheses. That formula then will automatically give me the numeric answer that I'm looking for in units of metric tons. Let's say that I have one of those pieces of information in there incorrectly. Instead of the area of Chicago being 535 kilometers, it was 355 kilometers. I inverted two of those numbers. As soon as I go to cell F1 and correct that incorrect information in that cell, that the new data automatically updates in the calculation that I've written, preventing us from being forced to repeat that whole calculation, which was kind of time consuming to put into the spreadsheet.